Now, we've already seen the general power rule, so this is not exactly shocking to anybody, that the derivative of u to the something is bring the power down and multiply it by u to the p minus 1. It's right here. Rule number 4, right? U to the something says n times u to the n minus 1 times u prime. So that's all well and good. So this is number 4 on the derivative sheet. However, we've done a million of these in Calc 1, so we don't really need to review that. What we do need to review is the tower function, because the tower function puts the logarithmic and exponential to the test along with the power rules. All right, so what is a tower function? A tower function is, well, something like this. A tower function is when you have a function in x and it's raised to another function in y, or another function in x's power. All right, well, that means that the power rule itself does not apply, not directly. So we have to be tricky about it. Now, there's two ways to do this. You can do this in an exponential way, and you can do this in a logarithmic way. So let's start by exponential. So we're going to exponentiate. Let's do that method over here. All right, so now the function was y equals 3x to the 7x. But if you'll remember, the previous page said, actually it was a couple pages ago, that we can rewrite a general exponent as e to the x natural log of b, like this. So I can rewrite this as e to the, I'll just write it this way, e to the natural log of 3x to the 7x, which is the same thing as e to the 7x natural log of 3x. It's the general exponential function definition right here 2 pages ago. So see page 88. I'll make a little comment. Right? It's the general exponential function, FCN, definition from the previous page. Okay, so how in the world did this help me? You're thinking, this is not any better for taking the derivative of this thing. Okay, well, I want to take the derivative with respect to x of all of this. Okay, so the derivative of this side is dy dx. So dy dx is equal to, I'm going to put that further over because I got to write a lot for this first step. Hold on. Okay, now's where the power rule comes in, because now I'll be able to make it work. Well, it's not really the power rule, it's the exponential rule. Right, but then it'll have powers inside. So the derivative of e to the something, right? I'm going to do the outermost portion first. The derivative of e to the something is e to the something. So I'm going to take the derivative, which is e to the 7x natural log of 3x. No problem there. All right, now I'm going to take the derivative of the inner portion, but the inner portion involves product because those are two functions that are multiplied. So I'm going to take the derivative of 7x, which is 7, leave the natural log of 3x alone, plus leave the 7x alone, and then the derivative of natural log of 3x. Oh, that's a chain rule. So that's, here, give me 1 second. I got to change my color options. There, I changed it to green. So I'll leave the natural log of 3x alone, plus 7x, and then now, derivative of natural log of 3x is 1 over 3x times 3, like that. So then I can kind of simplify this down a little bit. I mean, for starters, look at, you have a 3x here and a 3 here. So those 3's kind of go away. You have an x here and an x here, so those go away. So you're just left with 7 back there. So, and then this is e to the, and I can rewrite this. I can make the 7x go up. I mean, why not? E to the natural log of 3x to the 7x, right? I can pop that 7x up there. And then times 7 natural log of 3x plus 7, because that's all that's left in this back term is a 7. All right, well, you'll notice both of those have 7s in them, yes? So I could factor a 7 out. So if I factor the 7 out, and then I also notice that this right here, e and natural log, are inverse functions of each other. So that would be 3x to the 7x right there, again because of inverses. And then that would leave me this bit left over. I took the 7 out, but I have the natural log of 3x plus 1 left over because I factored out that 7. All right, so that would be the derivative according to the exponential method. That's dy over dx. Now, let's see if we can do it with the other method, the logarithmic method. And if it's right, then they should match each other. Me personally, I actually prefer the logarithmic method, but some people prefer the exponential method. Logarithmic. Okay, again, we start off with y equals 3x to the 7x. And so I can take the natural log of both sides because I can. So the natural log of y is equal to the natural log of 3x to the 7x. Now, why in the world would I do that? Well, I would do it because then I can bring the 7x down because of the logarithmic properties of the power logarithm property. So I can rewrite this as the natural log of y is equal to 7x times the natural log of 3x. And that's multiplied. All right, so now if I want to take the derivative of both sides of that, right, it's going to be the same amount of steps, really. It's just going to be a slightly different way of thinking about it. All right, so the derivative over here would be, well, the derivative of natural log is 1 over y times dy dx, right? That's the chain rule. So you take the derivative of 1 over y, but then the derivative of y with respect to x. That is equal to, and then it's the same power rule or product rule we used over here, same one. So you would write 7 and then natural log of 3x. I'll just use this color. And then plus, actually, forget that. I'm going to make it green. 1 second. There we go. So 7 natural log of 3x plus, and then again, it's going to be 7x times 1 over 3x times 3, right? You write it all down for your notes because you never know what you're going to be doing. But again, all of those things cancel. So that leaves you 1 over y dy dx is equal to, and then I can factor the 7 out. So there's a 7 in both of these terms. So 7 comes out, it leaves me the natural log of 3x plus 1. Because 1 is all that's left in here, right here, that little 1. So plus 1. I'll write it with a green so you guys can see it. All right, so to get dy dx by itself, all I have to do is multiply both sides by y. So it's 7 times y, and then times that whole thing, and then in the parentheses. So you have a 7, you multiply both sides by y. So you times this side by y times this side by y. And then you're left with the natural log of 3x plus 1. Oops, I forgot. I was doing that in green. There we go. And then the last step would just be to substitute back in what y was. Y was 3x to the 7x. So it's 7, and then y right here is 3x to the 7x. This should be looking familiar to you. And then it's the natural log of 3x plus 1. Ta-da! It's the same thing as the other side. And there we have it. That's dy dx. Both sides are exactly the same. It's just a question of how you get there. Usually people find it difficult on logarithmic side to remember the properties of logarithms, that you bring the power down and then find the derivative that way. And then over on here on the exponential side, it's this messing around with the exponent here that makes it a little tricky. You can put the 7x up, and then these are inverse functions, so they unravel each other, etc. But they're basically the same level of difficulty. It's just kind of whichever way you want to go and makes you happy.